Now in physics, we have something we call as a sound barrier. What is it? In jet planes, we're not allowed to break or exceed the sound barrier in the airspace over most cities. When an object travels at a speed or at or greater than the speed of sound, it creates something called the sonic boom. The boom is the result of the shock wave created by the motion of the object higher than the speed of sound. That's the boom you hear sometimes in the sky when you are near a place where there is some military grade airplanes in the sky. That's where the airplane will be faster than the speed of sound, so the sound waves of that airplane will combine together and explode with one exact shock, or what we call as a shock wave. Now for the boat, we have bow waves. A boat moving through water will produce a bow wave. That's what happens when you move your finger in the cup of water. The crest of the wave moves sideways away from the object, producing waves characteristics as V-shape. For the airplane moving through the fluid medium of the atmosphere or air, V-shaped bow wave or pressure wave travel outward at the speed of sound. Now, if the speed of the airplane is less than the speed of sound, the bow wave produced at any instant lags behind the bow wave produced just an instant earlier. So the bow wave carries energy away from the plane in a continuous stream. Now, what happened in the sonic boom exactly? For the airplane traveling at the speed of sound, the bow wave and the airplane travel at the same speed. Instant by instant, the crests of the bow wave are produced at the same location as the crest of the bow wave produced by the plane an instant earlier. The energy stored in the bow wave becomes very intense to the ear of an observer. Crests of successfully produced bow waves arrive simultaneously in what is known as the sonic boom. In the early attempts to surpass the speed of sound, many airplanes were damaged. At the speed of sound, there is marked increase in drag and turbulence. This effect damaged airplanes not designed to withstand it. A reporter assumed the increasing drag acted like a barrier to traveling faster than the sound and coined the term sound barrier. Mathematically, from the argument presented above, the Doppler wavelength can be given as lambda d would equal Vw minus Vs over Fs. So here we have the airplane slower than the speed of sound, so the waves would be following each other, while when you're at the speed of sound, the waves are happening, the previous wave and the current wave are happening at the exact same moment. At supersonic, when the airplane faster than the speed of sound, then those waves are combined together, gathering too much energy that will explode to be left behind the airplane, as we can see here. Now, if the plane is traveling at the speed of sound, Vs would equal Vw, which means for any sound produced by the jet, the Doppler wavelength in the direction of the jet motion is 0. If the plane's speed is greater than that of sound, the bow waves still combine to form a shock wave. In this way, a sonic boom can be heard for any object such as rifle bullet that has supersonic speed.